Any questions before we get back into volumes? So we spent the last couple class periods about doing volume, but doing disc method and washer method, basically cylindrical discs, cylindrical washers. Now we're going to be doing, still finding volumes of revolution, but by a new technique called cylindrical shells. But before we get into that, I want to. So let's just talk about kind of some of the process we talked about last time. So we did a bunch of volumes, so I'll draw kind of something generic. Let's say this is the shape I want to rotate around an axis. If I want to rotate around the x-axis, then what kind of cylinders, what kind of washers am I going to make? They're going to be dx rectangles that are vertical, or they're going to be dy rectangles that are horizontal? Yeah. They got to be dx, right? Because when I take a rectangle like this, what's the shape that it makes when I wrap it around the x-axis? It's going to make this, like this cylindrical disc with another disc punched out in it, or a washer. So yeah, we're still sticking with cylinders, but I think something I mentioned briefly when we were doing this last time is the thing we're integrating on really isn't area. So I'll just write down basically the kind of template we've been following for the disc method. It's the integral from a to b of pi times some radius function squared dx. So let's just remind ourselves, where does this pi r squared come from? What is this? Volume of a cylinder, right? So the pi r squared, this right here is, like, just this piece of it is the area of a circle, right? And then this right here is the height of cylinder. So if I multiply an area times some kind of a change in length, change in distance, I will get a volume. That's where my third dimension comes from. So in this case, I'm going to do something a little different. So I have this area here. I want to revolve it around the y-axis. So if we were going to do this the way that we've done it, what kind of rectangles would we have to use? Those would have to be dy, right? So what this method is going to allow us to do is going to give us some more freedom. So basically, what we're going to build up is this. I want to find the volume of this shape as I rotate it around the y-axis, but I'm not going to use dy rectangles. I'm going to use dx rectangles. If I take this rectangle, and again, every kind of integration we do is based on Riemann sums. So because of that, they're all rooted in a rectangle. If I take this rectangle and wrap it around the y-axis, what is that going to look like? It's a cylinder, but it has, unlike the cylinders we've made before, this thing is going to have, almost no thickness. The thickness of this cylinder is going to be whatever that dx is. But still, we're dealing with cylinders and we understand how to find their volumes. So what I did right here is the disc method. When we do the disc method, the thing that we're integrating on is the area of a circle. Is a circle a part of a cylinder? It's the top and bottom base, right? But now what we're really doing is, here's my dx. If the dx is the little change I'm allowing to happen in x, then I'm no longer adding area to the top and bottom of the cylinder. I'm adding area to this other part of the cylinder, right? What kind of shape is that part of the cylinder? The side. It's a rectangle. So if you were to like unspool it, like it's not flat right now, but it is a rectangle. So because of that, we're going to find the area. Basically, we're going to be integrating over the area of some surface of a cylinder, but now it's going to be that other area. How do I find the area of a rectangle? So the area of a rectangle in general is base times width. Maybe I should write those out in words. So that's in general how to find the area of a rectangle. How do I find the area of this rectangle that's part of a cylinder? How long is it? It's the circumference, right? So how do I find the circumference of the cylinder that I made here? So it should be 2 pi times whatever this radius is, right? So 2 times pi times the radius in terms of x. How do I get the other dimension of this rectangle? So the 2 pi r will give me the length. Where am I going to get that other dimension from? Well, so far, this is just one dimension, right? This is length. Or to take Bella's word here, this is the base, right? So let's try to go for consistency. This right here is the base. So I need 3 dimensions. So I got the base. What's the width going to come from, or the height, whatever you want to think of it as? It's going to come from the function, right? Well, they both are. So the radius is going to come from what about the function here? The x value or the y value? That comes from the x value, right? What's the height come from? In this case, it's going to come from the y value. But eventually, for now, I'll just leave the all the variables out of it. So here's my base. I want to multiply it by the height as well. So there's my base length. Here's my height. I have 2 dimensions. Where's my third dimension going to come from? That's going to come from my dx. So multiplying the base times the height gives me the area of a rectangle. And then multiplying by the dx gives me the thickness. Multiplying all 3 of those things together gives me the volume. So clean this up a little bit. The shell method, basically, just like the disk method, I am integrating over the area of some part, some surface on a cylinder. But in this case, I'm not doing the base, I'm doing the sidewall. So that's why the shell method is set up this way. So I hope and I think that things will start to clear up after we do some concrete examples. But for right now, any questions about the way I developed this, the way this is structured? Or do you not know what you need to ask me yet? Okay, so let's try to clear some of these things up by putting some concreteness to it. So here's this function. This is y equals 1 over 1 plus x squared. And just like I described, I want to find the volume of this thing as I revolve it around the y-axis. So because right now I'm dictating that we use the shell method, we are going to use dx rectangles. So then if we're going to set this up using the shell method, so the volume is equal to the integral from a to b of 2 pi times the radius function times the height function times dx. So basically we have 2 functions we have to define, a radius and a height. And we got to define that basically for every rectangle I might be able to draw inside. So earlier you just said that the radius was given by what, X or Y? X, right? So when I set up the shell method here, my radius is going to be simply X. Because the radius of each of these cylinders I'm going to make is going to be dictated by how far the rectangle is from the thing I'm trying to rotate it over. So that is going to be purely the X value. What's the height going to come from? The height comes from Y, right? So if I want to know how tall each one of these things is going to be, it's going to come from how high up on this curve I am. So the height function is going to come from Y, but I can't use Y in my integral, right? I have to re-express it in terms of X. So in this case, we do know what Y is in terms of X. We okay so far? What else do we need to do to set this integral up? Do we know the bounds? Should be 0 to 1. It might be a little hard to see, but yes. If I want to go from the x-axis or the y-axis, that's x equals 0. Terminates at x equals 1. And I'm integrating this function. X times 1 plus 1 over x squared. Yeah, you're right. Thank you. So that is the integral. I'll ask for all of them.
Will it always be like X, or does that like depend on?
So it depends. So in this case, we are rotating around the y-axis. Kind of like with the last section, we will kind of generalize that axis. Like I could move it a couple units to the left.
So that would be like if you're moving it to the left, it would be like X minus 2 or something, or like
X plus 2, but yeah, you have to adjust it depending on. So the constants that, or I don't want to say constant, but the things that I can promise you can rely on are basically you are going off of this rectangle. So as long as you define the radius and the height in terms of whatever variable you're trying to work with, you're going to be fine. It's not always going to be as simple as X like it was here, but yeah, basically the big things we need to do for shell method are to define the radius and the height.
So for the shell method, when it says rotate around the y-axis, then it's going to be dx instead of that.
Right.
It will always be that way.
That is true, because if you think about it this way, if I want to rotate around the y-axis, there are two kinds of rectangles I can make. There's the one I left behind, and there's also this, a dx and dy rectangle, right? If I rotate the dx rectangle around the axis, I get a thin cylindrical shell, right? Like a sheet of paper towels. What happens if I take the dx rectangle, or sorry, the dy rectangle, and wrap it around the y-axis? That's a solid disk. So basically, whether you're doing disk method or shell method is going to depend on the combination of those two things. What variable am I integrating on? And what does the axis look like that I'm going to rotate it over? So that combination of things dictates the method. So for example, if I were to use a dy rectangle and wrap it around the axis here, so if I was going to set this up in terms of y, but then I started setting up the shell method, I'm not even finding the right areas. So you really have to be careful with what's the combination of things I'm looking at. So let's write those down. So basically, question 1 we talked about last time. Am I doing dy or dx rectangles? So that's one question you have to answer for yourself. What's the other one we have to answer for ourselves now?
The bounds.
Not so much the bounds, because like, I mean, yeah, you do have to do that, but the other thing you have to think about is this: is it a vertical or horizontal axis? So now you have both of these at your disposal. It is the disk method and the shell method. If I say I want to find a volume by revolving this region around the y-axis, yesterday when all we were doing was disks, then that was all the information you needed to say that, okay, well, I better be using dy rectangles. But now, because you have both methods, you have a little more freedom to choose, but you got to make those choices in an accurate way.
On the exam, you will tell us which one.
Not necessarily. So let's do a few more examples, because in many cases, both are fine. In some cases, one is much more difficult than the other. So we'll talk about that as we go. But yeah, that's going to be a hard question for me to kind of answer for you in the abstract so I'll show you a couple more of these things. All right. Any more questions about where this integral came from? Is this one we can do by hand? How so? U substitution should work. So let me, we can pull out the 2 pi because that's a constant. I'm gonna go ahead and combine the x and the 1 plus x squared. I heard a vote for U substitution. What U would you like to use? 1 plus x squared, which means du is 2x dx. So how does that help us with our integral? Is it still 0 to 1? Or will x equals 0 to x equals 1? For now, I'll leave it as x equals 0. X equals 1. So is this something just 1 over u to u? Okay. What happened to all my 2's? They canceled out. So one thing I will say here is, from this we can get that x dx is equal to 1/2 du. So that 1/2 canceled the 2. So yeah, this integral ended up, through substitution, looks quite a bit simpler. Before we actually compute it, can we get the bounds? What are they? Okay, more importantly, why are they 1 and 2? Plug the x values into what? 1 plus x squared u. Right, so I have a recipe that turns x's into u's and vice versa. So if x equals 0, u equals 1, so on. All right, what is this integral? Yeah, so pi times the natural log of u from 1 to 2, which equals, should just be pi times the natural log of 2, all told. Questions there? So to Pia's question from a few minutes ago, let's say this. Let's say I wanted to do this by disk method. So let me set up a dy rectangle. First of all, disk or washer? Should be disk, right? So one consideration to worry about. If I do disks, what's the radius of that disk going to be? It'll be the curve, right? But will it be the curve everywhere? No. If I fall below this point here, then the radius is just 1. So because of that, I already need more than one integral. But also there's this. If I'm going to set this up using disk method, I have to do it in terms of y, right? So pi times the integral from a to b of f of y, or radius of y squared dy. Can I solve this thing here for x? Is it going to be as friendly as the way it's written now? So I think it could be done. I don't think it's going to be anywhere near as straightforward as what we just did. So sometimes your choice on disk method or shell method is going to be dictated by what integral you'd rather do. Sometimes, like in this case, I think it'd be very difficult. In other cases, I think it'd be absolutely possible to isolate a certain variable. But I think in this case, shell method is more appropriate for the thing we wanted to do. So moving on. So what would you like to do first based on what I have for you? Let's do a graph. I don't know if I have a very good idea what this looks like. So what's the region bounded by? So that curve and y equals 0. Can I find where that curve crosses the, I want to go around the y-axis, right? I would really like to find out where this thing crosses the x-axis and y-axis, x and y-axis. So I'm going to set it equal to 0, or I'm going to set the y's equal to each other. Can I solve that equation? I can factor out an x squared, so I get 2 minus x equals 0. So that should give me x equals 0, x equals 2. What happens in between those values? Is it above the x-axis or below it? It's above it? Okay. So really, really rough, but hopefully good enough to do what we want. Is this the region I care about? So here's my y equals 2x squared minus x cubed. Y equals 0 is the x-axis, and that's it, right? That should be the region I want to revolve. And I want to rotate it around the y-axis. So if I want to use the shell method, what kind of rectangles am I setting up? Dx rectangles. So in this case, another way to think about the disk and shell method is, are my rectangles going to be parallel to the axis I'm rotating over, or are they going to be perpendicular to it? So for the shell method, what's the answer to that question? They're parallel. So I'm making vertical rectangles to wrap around a vertical axis. So if we're using shell method, how do we set that up? 2 pi times the integral from where to where?
0 to 2.
0 to 2. Good. So for right now, let's be clear. What is the radius of all these cylindrical shells going to be? In the last example we did, it was purely x. Is that true again?
No.
How far are these rectangles from the axis of rotation? So if I draw a rectangle at 1, how far is, like, what's the radius of that cylinder going to be? 1. Let's say this one right here is at 1.6. What's the radius of that cylinder going to be? I think radius is simply x again. How about the height? What's that going to be?
2x squared.
That's going to be the y we started with. So 2x squared minus x cubed. So I think that's good for our integral. Radius is x, height is 2x squared minus x cubed. And then dx is the thickness of all those cylinders. So I think this is a good integral. Let's pause here and talk about where it came from. Any questions about how we got that? Go ahead.
I'm slightly confused on how we're doing that.
Sure. So let me get rid of all this stuff in here. So basically the radius refers to, I want to know how, basically how big around these cylinders are. So basically to get that information, so let's draw a rectangle in here. And I'll actually draw the cylinder that is going to get made if I revolve it. So there's a very bad drawing of the cylinder. So I just drew a cylindrical shell. What is the radius of the cylindrical shell? Or how do you find the radius of it?
Well, is it the distance from the axis?
It's the distance from the axis to wherever the rectangle is, right? So no matter where I draw this rectangle, basically I'm comparing the x value that I care about to the y-axis, whose equation is x equals 0. So I could say, all right, I'm comparing two x values. One is the x value that I'm, on the curve that I care about, and one is a constant x equals 0.
So will it always be x?
If the axis of rotation is the y-axis.
What would be if it's the x-axis?
If I say I want to rotate this around the x-axis, that's a good question.
That would be y.
So if I want to rotate this around the x-axis instead, what has to change? I have to change to a dy rectangle if I'm going to stick with the shell method. So that's one thing that has to change. I mean, the point is basically everything would have to change, because instead of rotating over a vertical line, I'm rotating over a horizontal line. So I would either have to do a brand new method, or I would have to integrate in terms of the other variable. So a lot changes from that seemingly very small change in your decision. Anything else about this integral? Can we calculate? So I think I would like to do some simplification. So the integral of 2x cubed minus x to the fourth. So the integral of 2x cubed is 1/2 x to the fourth minus 1/5 x to the 5. One half of 16 is 8 minus 32 over 5. All right, someone double check me on that number. I think that's okay. So another thing to kind of point out here is, let's say instead I wanted to find this volume using disks. If I wanted to find this volume of this shape wrapped around the y-axis using disks, I would have to do dy rectangles, right? How do you feel about solving this thing for x? I don't know for sure, but I think that's actually impossible. So this is one of those cases where not only is it harder to do using this method, I don't actually believe it could be done.
Is it when you're looking at the function also the graph, your top and bottom are the same? So like, we some graph top and bottom.
What do you mean your top and bottom? Sorry.
Like if you're doing, in this case, like dy,
Mm-hmm.
and we would always do like.
Oh, I see what you mean.
So it's the same function.
Right. So yeah, you're comparing the same curve.
Right.
I don't even want to say function, because once you look at this in terms,
Right.
once you look at this in terms of x as a function of y, you can't even define that curve using one definition. So you'll, by definition, need a second integral. So a lot of different reasons that this is way easier using the shell method. But I believe this is one of those times where the disk method probably won't get you to the volume I'm asking for. Any questions here? All right. How would you like to start? Let's look at it. Unlike the last one, I know what these look like. But I really do want to find out where the cross first. So I'm going to set them equal to each other. 2x equals x squared. Two x squared equals 0. Okay, so I get x equals 0 and 2 again. So I know they're going to cross at the origin. I know they're going to cross out here somewhere. Okay. So I think my region's in here. I want to rotate it around the x-axis. All right. How should we do this? You want to use the disk method?
Yeah.
How come?
Just because of practice with that. Can't use the disk
Are you sure the disk method would work? Let's try it.
fairly sure?
Okay, you want to use the disk method. So I have told you I want to rotate around the x-axis. If you want to use the disk method, what kind of rectangles do we have to deal with? I have to deal with dx vertical rectangles. So let's try it. So I don't think it'll be disk method, but washer method, because I don't reach the x-axis, but sets up the same way. If I want to set this up using disk method, what does that look like?
0 to 2,
0 to 2, because I'm dealing in x values.
2x squared. Of like both 2 and x squared.
Okay. So the outer radius you're saying is 2x.
Yeah.
So outer radius squared minus the inner radius squared. What's the inner radius?
X squared.
So 2x squared minus x squared squared dx. Is that an integral you believe you could do? I agree that you could. So this right here is disk method. What about the shell method? Would the shell method even work? If I want to use the shell method, what kind of rectangles do I need? I need dy. So if I want to use the shell method, that's going to be the volume of what bounds? 0 to 4 this time. Why is it 0 to 4 this time? I want the, yeah, I want.
The rectangles are parallel to the x-axis.
Right. The rectangles are parallel to the x-axis, which means they're dy rectangles. So I want y bounds. So what's the function I'm integrating? 2 pi times. What's the radius? Is the radius just simply y? So this rectangle I made here, I'm going to revolve this little rectangle around the x-axis, right? So how do I describe the distance between that and this? That is y. So I think we just said that if you're doing vertical shells, that if the axis of rotation is the y-axis, the radius is just x. So by that same logic, the radius is y.
So is it only not just x or y if your axis rotation is not?
Yeah, if it's somewhere else. Yeah, then you have to account for it. All right, so the radius is y. What's the height of these rectangles that I'm making? Or really it's length in this case, right? So basically the height is going to come from this, right? It's going to come from whatever this bigger x value is minus this smaller x value. So basically it's the curve, it's the x value from the curve minus the x value from the line. So it should be square root of y. How come?
You're solving for the,
Right, so x equals radical y. And y over 2 minus y over 2. So one caveat here. When you're doing disk method, you square these radii, right? So this order doesn't really hurt you, even if you get it wrong. That is not true with the shell method. So let's ask this, did we subtract this in the correct way? We should have, yeah. Radical y better be greater than y over 2, at least in this region we care about. So which one of these was harder? Disk method or shell method? Shell? So, but we were able to do both. I sort of wonder if the shell method was only harder because you were only doing it for a little bit. But really, this is one of those cases where either method will get you there. It kind of it's a personal preference thing, whichever one makes more sense to you. But now that we've got it set up both ways, question?
Is it fair to assume on the exam you'll tell us which method you want us to?
It's not. It's I might not.
Okay.
So, but in the cases where I don't, yeah, it'll be on you to figure out which one makes more sense to you. But
Will the different formulas be given for like shell method versus?
probably not. They weren't last time. So that's part of the reason I'm really harping on the fact that these come from basically the thing we're integrating on has to do with the area of some face of a cylinder. Either it's a rectangle for the shell method or it's a circle for the disk and washer methods. How are we doing? Okay. Right, I assume you're going to ask for a picture. Let's do it. Okay, so what are we rotating around? We're not rotating over the y-axis. So I think we said, or maybe we haven't said this. I want to know where this crosses the x-axis. So it's going to cross the x-axis at 0 and 1. But where's the axis of rotation now? X equals 2. So this is going to be one of those times where we don't get the radius for free. We have to be a little more careful about it. So my region is going to cross. It's above the x-axis, right? So here's the region I want to rotate around this line. Is there anything else I need to deal with? I think that's it. All right, so do we have a choice? What would we rather do? Disc or shells? Why shells? Because what's vertical? The axis is vertical.
Finding horizontal rectangles will be very
I
difficult.
think that's the thing that really is going to make this hard. Is if we do horizontal rectangles, how do I define the right end and left end of that rectangle? They both come from the same curve, right? Also, I'd have to solve this thing for x, which could be done, but it involves completing the square. And have a square root in it, a plus or minus. You're going to have two integrals. I think shells are going to be a much more straightforward thing. So here's my rectangle. All right, so I'm rotating around a vertical axis. I kind of just glossed over this, but are we okay with the fact that that means I need vertical rectangles? Okay, so this one's going to be a little different, so let's go through a little more slowly. The volume is going to be 2 pi times the integral from a to b of radius as a function of x times the height as a function of x times dx. Do we know the bounds, first of all? We're going to vote for 0 to 1 and vote for 0 to 2. We agree on 0. So where's the right end of this region?
I mean, it's 1 because your radius account for 2.
Yeah, so basically the question to ask yourself about how to fill in the bounds of the integral is about basically where does this region exist? So yes, even though I want to revolve it around x equals 2, there is nothing, for example, in here that contributes to that area. So my bounds are going to be strictly between 0 and 1. All right. Let's get the height out of the way. What's the height? The height simply comes from y. This is the thing we have to be careful about. What's the radius? Yeah, let's write that down and let's talk about it. How do we feel about the radius of 2 minus x? So really, to find the radius is going to be how far this rectangle is from the thing I'm rotating over. So this right here, I'll just call generic x. How far apart are x and 2? Should be whatever the difference is between them, 2 minus x. Is x minus 2 okay? What do we think? No. Why not? It would give you negative radii. And since I'm not squaring it, there's no, like I'm not going to be saved by the geometry that you get saved by in the disk method. So I really want to subtract my larger value minus my smaller value. And all the x's inside my bounds are going to be smaller than 2, so I want to go 2 minus x. So now that we have all the ingredients, I'll pause for a bit. Any questions about how we define the things we define? All right, so I think we're ready to set this up. 2 pi times the integral from 0 to 1 of 2 minus x times x minus x squared dx. Is this an integral we can do? Yeah, we need to simplify first. So what do I get? Positive x cubed? Oh yeah, yeah.
I just flip the order around.
Okay. Oh, do I get 4 different powers out of this? No, I don't. Yeah, the weird order confusing. I can't
Yeah,
figure out what I
sorry.
missed.
The other one is two.
Oh, no, plus 2x is the last one, right?
Yeah.
And I will combine these right now. Minus 3x squared plus 2x. So 2 pi times 1/4 x to the 4th minus x cubed plus x squared from 0 to 1. Is that simply pi over 2? How are we doing?
How did you get 2 minus x?
Good question. So the radius, that is the real big wrinkle from this example, is the fact that the radius is not simply x or y. So why did we get 2 over x instead of just x this time? So the radius of all these cylinders, maybe it would help if I drew an actual cylinder. How do I draw this cylinder? It's not like that. It's like, so I don't know if I have enough real estate to do it, but we'll do it anyway. So basically take this, and why am I doing it over here? Yeah, so x equals 2 is the center of rotation. So if that's a cylinder that I make from that rectangle, let's just go back to the base definition. What does the radius of a cylinder tell me? By definition, what does that word mean? Distance from the rim, the edge of the cylinder to its center. So basically, I want to find this distance right here. From here to here. So that distance, is that going to be a horizontal measurement or a vertical measurement? So I'm comparing two vertical values. So if I'm comparing the distance between two vertical lines, I think that distance is going to be something horizontal, right? So how far apart are 2 and x? Let's do this. Let's say that x is equal to 0.4. If that specific x value is 0.4, what's the radius of the cylinder that I just drew? 2 minus 0.4, so it should be 1.6. So basically, because I'm rotating around this other vertical line, the way I'm going to get the radius is to compare, or basically figure out how far is this x value from x equals 2. And if I want to compare distances, I'm taking a difference. So how far apart are x and 2? That's 2 minus x. So did that help a little bit?
Yeah.
Okay. So that is going to be, and I think like it was with the disk method, that when the axis of rotation is somewhere different than your coordinate axes, there's going to be some care you have to take to make sure you're getting that accurate. Any questions here so far? So disk method, washer method, shell method. Hopefully now that we've seen a few examples of shell method, we can kind of see why one might be valuable, what another might not be. Go ahead.
On the last example, I'm a little confused on why you went with dy versus dx rectangles.
Yeah, let's talk about that. Why did we do dy rectangles? For rotating around a horizontal line. So if we want to use, and really we did both on this one, right? So let's be really clear about what these two things are. This right here is what? Disk method. And this right here is shell method. So one of the things the shell method requires is that your axis of rotation and the rectangles you're building it on are parallel to each other. So because I was rotating over a horizontal line, I need horizontal rectangles, and horizontal rectangles have dy as their thickness. That's the big difference between this and I think everything that came before it. This was the y-axis, so we used x as our variable. This was the one rotate of the y-axis, so we used x as our variable. So for the shell method, that's the real, that's kind of the bottom line, is the rectangles you are making your cylinders out of have to be parallel to the axis that you're revolving over. Good question. And like next time we'll talk more about how to kind of make those decisions between these two methods. Anything else? All right, I'll see you all either in my office hours or on Friday. Take care.
I do have another question.
Yeah.
So this one about the y-axis, so I'm doing it in terms of dy.
This is from last time?
Yes, this is
True.
the 7.2. So I'm doing it around dy, and I'm doing like the like not the what's it called? The one where there's the hole. Yes,
Okay.
and so
If you're going around the y-axis, I believe you need to do dx rectangles to do the motion. Because basically you have this curve, right?
mhm,
If you want to make washers or discs, or it doesn't matter, you're going around the y-axis, you said,
mhm.
then you want this, if you rotate it around. I'm sorry.
Yeah.
Yeah, I'm just talking myself into it. Okay, I believe you. I don't know, I'm
So
sorry. I was in shell mode.
I just have no idea why I'm getting it wrong.
Okay, so the region bound by y equals x cubed,
And I think it's-
y equals 0, and x equals 3. So in your mind, where's the region here?
it's like right here.
Okay, it's underneath, right?
Yeah.
So it's down here. Rotating around the y-axis.
Mhm.
So what are your bounds for your region?
Then you have to plug in the 3. So those are 0 and 27 are the y.
You do.
So 0 and 27.
Okay, I agree with that. What's the radius
The-
or the outer radius?
Isn't it 3?
The outer radius is 3, so 3 squared
Yeah.
minus.
Minus the cube root y. So why am I getting it wrong?
I don't know. That looks good to me. Well, one question was this.